Okay, in this video we will talk about connectives. Okay, so if you remember from my previous video, we talked about negation of a proposition, right? So where we have used the negation operator on a single proposition to make it a negation, right? So now connectives we use to create another proposition from two or more propositions. Okay, that means we will be basically connecting two or more propositions by using some operators. Okay, those operators generally we called as connectives over here. Okay, to form a new proposition. Now, so that means if I just write it down, we use connectives, okay, to create proposition from two or more propositions. Okay, two or more propositions over here. For negation, only the single proposition was there. Now we are dealing with two or more propositions over here. Okay, now there are mainly three connectives we'll be working today. Okay, we'll be basically learning today. So those are, so let me bring up a table over here. Okay, then we will discuss them. Okay, so there are three connectives. One is conjunction, okay, another is disjunction, or sometimes it is called inclusive-OR as well. Okay, inclusive-OR, and there is another one called exclusive-OR over here. Okay, exclusive-OR. Now in conjunction, it's basically a AND operator. That means if I just say P and Q are two propositions over here, then the conjunction operator is basically an AND operator. So we say the conjunction of P and Q will be P and Q over here. Okay, so if I just write it down over here in a separate color, conjunction of P and Q, it is generally written as P, okay, then and Q over here. Okay, so that means we are basically using an AND operator over here. Let me give you an example over here. Okay, so let's say we are analyzing a statement called it is raining today. Okay, example, let's say it is the sun is shining, okay, and it is raining today. Okay, so if you see it over here, if we just analyze this particular sentence over here, there are two propositions over here, right? One is this portion, the sun is shining, right, and another is it is raining today, right? So if I just say my P, if I just say P equals to the sun is shining over here, okay, and Q equals to it is raining today over here. Okay, so let me bring it to a separate line. Okay, so the above statement we can write it something like this one: P, then and Q, right? So the above statement can be written something like this one. So if I just write it down, or let me copy this one and paste it over here. Okay, so this particular statement can be written in something like this one: P and Q. Now if we just develop the truth table over here, so this particular statement will be true only when both P and Q will be true. okay, otherwise it will always be false over here. Okay, that means both the proposition has to be true, then only this whole conjunction, this composite proposition will be true, otherwise it will be false. So if we just develop the truth table over here, so if I just write P over here, right, and Q over here, and P and Q over here, okay, so if P equals to true, Q equals to true, then only this will be becoming true over here, right? If P equals to true and Q is false over here, then whole expression will be becoming false over here, right? Now if P equals to false and Q equals to true over here, then also this whole expression will be becoming false. And if both of them are false over here, okay, so then the whole expression is also becoming false over here. Okay, so this is the truth table of this guy over here, right? So only it will be only true on when both of these propositions are true over here, right? So now if you see this particular sentence, right, the sun is shining and it is raining today, it can also be expressed in this way in our natural language. So if I just write it down, this particular sentence, generally we use but over here, right? So this is also a conjunction in mathematical logic. Okay, even though in our natural language we are basically expressing some contrast over here, generally this does not happen, right? When the sun is shining but it is raining, it does not happen very frequently over there, but it happens, okay, sometimes. But in mathematical logic, this is still a this but actually a conjunction over here. Okay, we have to remember this one. So it is still equals to P and Q over here. Okay, now the next connectives we will be talking about today is called disjunction or the inclusive OR over here. Okay, so if I just start with same stuff over here, I'll also explain why we call it inclusive OR and why we call it exclusive OR over here. Okay, so let us copy this line over here. If P and Q are again two propositions over here, okay, so let me copy this one as well. Okay, so here instead of conjunction we'll be writing disjunction here, right? Disjunction of P and Q. Okay, so P and Q will be P or Q over here. The expression, we generally express the OR in this way, V. Okay, so that means now in terms of truth table, let us discuss that one first, okay, because that will be making sense more. So now if between P and Q, if one of them is true, okay, at least one of them is true, then this particular statement we call it as true over here. Okay, this is called inclusive OR. Now what type of places we use inclusive OR and what type of places we will exclusive OR, we will see that one. Okay, so let us try to build that truth table first. Okay, then we will talk about the other stuff over here, the difference between these two. Okay, so we will first talk about the truth table here. So we'll write P, okay, we'll write Q, and we will write P or Q over here, right? P or Q over here, right? So if P equals to true, Q equals to true. Okay, so as I said, like if both are true, that is also, then also this whole expression becomes true over here. Okay, at least one of them is true over here. Okay, it can happen that both of them are true as well. In that also, that particular OR expression is becoming true over here. Okay, so if P equals to true, Q equals to false over here. Okay, so this expression is becoming true over here because P is true over here. If P equals to false, q equals to true over here, so this also becoming true over here, this particular expression. If both are false, okay, then only this particular expression is becoming false over here. Okay, so this is inclusive or disjunction. Let us try to develop the similar stuff for exclusive or as well, then I will give an example. Okay, so we'll just copy this line over here. So let us say again p and q are two propositions over here. Okay, I'll copy this guy as well. Okay, so here this is exclusive OR, right? Exclusive OR of p and q, generally it is written as plus within a circle over here. This is the exclusive OR symbol over here. Okay, so let us try to build that truth table over here. So we have p, we have our q over here, and we have our p exclusive OR q over here, right? P exclusive OR q over here, right? So if p equals to true, q equals to true, this particular case, this expression is becoming false over here. Okay, so this is, that means at least when we talk about inclusive OR, we talked about at least one of them is true, right? Here in exclusive OR, it has to be a case either p or q will be true over here, then only this particular expression becomes true. Okay, if both of them are true, this particular expression is again false over here. Okay, we'll see an example. Okay, so if p is true, q is false over here, so this time this is true, right? Because one of them is true. If p is false, q is true over here. Okay, again this is true because one of them is true, and if both of them are false, again it's a false case, right? Now let us talk about an example over here. Okay, so I'll just go down a bit. So first we will take an example of inclusive OR, then we'll take an example of exclusive OR. Okay, so if I just take an example, let's say I have a sentence called something like this one: citizens of Canada, okay, speaks either, okay, I'll just make it down over here, okay, so that I can write in a single line, either French, FRENCH, or English. Okay, so if I have a sentence something like this one over here. Okay, so now think about this one. What are my propositions over here? So if I just write P is my propositions, so citizens of Canada speaks French, right? And my Q will be citizens of Canada speaks English over here, right? So now think about this one. So basically we are talking about, because there is a OR over here. Okay, we are talking about P or Q, right? So if I just copy this one, we are basically talking about this one over here. Now think about this one. There could be a citizen who knows both of these languages over here, right? Both English and French over there, right? So this is a case of inclusive OR. That means if we are talking about these scenarios over here, right, it can, both of these propositions can be true as well in this particular scenario, right? So this is a inclusive OR case. Now in computer science or in mathematics generally, when we talk about OR, we generally talk about inclusive OR over here, right? Until and unless we are explicitly mentioning whether it's an exclusive OR or not. Okay, so this is a case for inclusive OR. Now let's talk about a case for exclusive OR over here. Okay, So example, let me go down a bit over here. Okay, now if I have a sentence something like this one, so every natural number, okay, is either odd, I'll go down, either odd or even. Okay, so if I have a sentence something like this one, now if you see it over here, we are still talking about an OR operation over here, right? An OR operator over here. Similarly, if I just derive my P and Q from here, right? So P will be like, I have a natural number which is odd. Okay, so every natural number is odd, or my Q could be my every natural number is even. Okay, now if I just join these two sentences over here using this either or, it's becoming this one over here, right? So every natural number is either odd or even. Now think about this scenario over here, they cannot be together both, right? A natural number can't be together odd or even, right? It can be either odd or even over here, right? So basically we are talking about this situation over here. In this case, both P and Q cannot be true together, right? So either it has to be P true or it has to be a Q true over here in this kind of sentence, right? So this kind of sentences generally we express as P exclusive or Q over here. Okay, that means this particular sentence will be false when both of these P and Q will be true over here. Okay, so this is the notion of exclusive OR and inclusive OR over here. Okay, and we also talked about conjunction, which is nothing but an AND operator over here. So it basically adds two propositions to glue them together. Okay, so hopefully this video is helpful. In the next video we will be talking about some more other stuff in propositions as well. Okay, see you in next video.